Hello guys, so we are back with one of the problem from TensorTonic. So today's problem is non-max suppression. So people who have built models like detection kind of models, so they are very much aware of like what this algorithm does. Okay, so if you guys have trained YOLO, okay, something like that, or maybe you have used DinoV2 for object detection kind of task. So we always observe like sometimes the model gives like multiple bounding boxes for the same object. Okay, so in that kind of scenario we want to eliminate or basically we want only one bounding box around our object, right? So if I show an example, okay, the problem has given the example. So we have faced this scenario, okay, where you can see like let's say there is this image, okay, and in this image we have multiple bounding boxes. Okay, let's say there is an object here. Okay, let's copy this image, paste it here. Okay, so let's say there is a person here. Okay, and let's say there is a person here. Okay, so it may happen sometimes your model gives multiple bounding boxes around these two objects. Okay, so in this kind of scenario we want only one bounding box. Okay, so having multiple bounding box overlay over an image, that's kind of confusing for the people. Okay, and because if further down, so like object detection is always kind of a you can say a pre-processor step for an algorithm. Okay, let's say you want to compute the distance between these two boxes. Okay, you have to select which box you want to keep, right? So in this kind of scenario we apply NMS. Okay, what NMS does is it just like select the best bounding box, and by best I mean the box having the highest confidence values. Okay, now whichever box, okay, overlap with our best box. Okay, so in this scenario you can see like I guess the blue bounding box should be the max one. Okay, I can do this. So if I zoom this a bit, okay, as you can see the blue bounding box has a score of 0.92, which seems like it's the highest. Okay, so what we will do is we will pick this blue bounding box, and whichever bounding box, okay, is highly overlapping with our best bounding box, we will eliminate those boxes. Okay, so if I show you the scenario here, okay, I'll run a step. Okay, you can see it has eliminated this orange one and the purple one with respect to the blue one. Okay, similarly for this region, okay, we again have multiple bounding boxes. Okay, I guess here the red one is the highest. Okay, it has a score of 0.88. Okay, so we should keep only this bounding box. Rest all the box which are highly overlapping with this box, we will simply eliminate this. If I run the step again, and you can see only the red bounding box is there. So yeah, now with respect to this, the thing is we should so in order to run this algorithm we generally have two thresholds defined. Okay, one is like confidence threshold. Okay, like uh, like even if to select our best bounding box, okay, how much confidence threshold should we have? Okay, is it like 0.9? So whichever bounding boxes are over 0.9 we should take those boxes. Okay, that can also eliminate few of the boxes here, right? Okay, so even with this confidence threshold there are certain cases where we can have multiple bounding boxes over our object. Okay, so in those, so in order to completely remove all those like overlapping bounding boxes, we use another threshold which is IOU threshold. Okay, now this IOU threshold is basically a overlapping threshold. Okay, it basically a threshold that tells us like how much overlap uh, like like how much overlap we can tolerate. Okay, so if any overlap crosses this threshold, we will simply discard that box. Okay, so yeah, this is the IOU threshold. So uh, it's a very simple parameter. Okay, so what it does is like let's say you have two boxes, something like this. Okay, so if you see at the overlapping region, which is this, okay, what we will do is IOU score will basically say, let's say for this box A, box B, okay, we will calculate the intersection region area, which is area of A intersection with B. Okay, and we will divide it with the union area. Now the union area is this thing. Okay, so I'll say A union B. Okay, so in order to calculate this, what I will be doing is I'll first calculate A's area, okay, which is this. Then I will consider B's area, which is this. Okay, now if you see, when I'm considering A and B's area, okay, the intersection area I'm calculating twice. Okay, so I'll be removing the intersection here. Okay, so with this I'll get this whole region union. Okay, so yeah, so if you can see, here's the formula, and this IOU calculation I'll be implementing as a function. Okay, and I will use this IOU function in order to calculate my NMS. Okay, so first thing first, okay, I guess they have also given the algorithm. We have to sort all the boxes with respect to the confidence score. Okay, so as you can see in the input, we have boxes given. Okay, we will be given the boxes coordinates. Okay, and we will be given the confidence threshold with respect to each box. Okay, and here is our IOU threshold. Cool. So first thing first, I need to get the boxes, or I have to get the highest box, like I have to get the box with the highest confidence. So for that I'll be creating an order. So I'll be saying sorted. I'll be sorting my scores. Okay, so I'll say range len scores. Okay, now here's the thing is I have to sort them with respect to the score value. So I'll be saying lambda I can dezoomify. Okay, lambda I colon scores of I, and I need reverse order. Okay, so that I will encounter the best bounding box first. Okay, so if I show you this print order, let's create a res also, because I'll be returning that. Okay, run. Okay, so I got the ordering. Okay, so here you can see like yeah, sorted by reverse. Okay, so the 0.9 box, so this box should come first. Okay, with respect to the scores. Okay, this box has a confidence value of 0.9 and this box has a confidence score of 0.8. Okay, for the second test case, you can see I got the one index box, okay, as my highest as my best box first. Okay, because the one index box has a score of 0.9. Cool. So order is correct. Then what I'll be doing is I'll be iterating over with respect to my order. Okay, so I'll say for I in order. Okay, so whatever index I got, I will check. Okay, so I'll create a flag first. Okay, overlaps. Okay, so I'll initially set it to false. Okay, and what I will be doing is, okay, so the algorithm here is, so res will be containing my best bounding boxes. Okay, so what I will be doing is I will iterate over all the bounding boxes with respect to this order. Okay, which is like the sorted scores. Okay, and if any of the boxes, okay, I'll show you in the code. Okay, if any of the boxes in my res, okay, b box in res, okay, I'll be storing indices. So yeah, if any of the bounding boxes coordinate, okay, overlaps with my current box, then I should discard it. Okay, so I'll be saying if I need to implement a IOU score, so I'll say IOU. So this will be taking two boxes, so I'll say b box A and b box B. Okay, and this will be returning an integer. Okay, for now I'll be implementing it later, but yeah, so I'll say if the IOU score, okay, of my boxes or b box I, okay, so the IOU score between my selected box, okay, and my current box which is coming from I, okay, so boxes of I, okay, if that is greater than my IOU threshold, which means like there is a very high overlap, okay, then I will be discarding that box. Overlaps equal to true, and since it has overlapped over one of my best selected box, I'll be breaking out of the loop, okay, so I don't need to consider this box, okay. Otherwise, if it hasn't overlapped over any of my bounding box, okay, or any of my selected bounding box, I'll say if not overlap, then I will be storing this index, so res of append of I, okay. Cool, I hope you understand this logic, okay. Now the second thing, I need to implement this IOU, okay. So I'll be first, so the box coordinates are given like this, okay. I have been given x1, y1, and here I have been given x2, y2, okay. Now the coordinate system here follows CV2 style coordinate system, which basically means as we go down, okay, the y value increases, okay. So x2 is greater than my x1, okay. So I'll first unpack the coordinates. So ax1, then ay1, then ax2, then ay2. These are my BB box A's. Then similar thing I'll be doing with B. This platform is good with the question, but for editing this platform is not that good because I cannot select my string selection that you have in VS Code or maybe in Lead Code. This platform doesn't have it, so yeah, no Control D or Alt D kind of thing you can do. Cool. So I got the coordinates. Now for first I will calculate my intersection or intersection area between the boxes, okay. Now I will just first go through the scenarios in which overlapping can happen, okay. So let's say there is a box A, okay. Now there is a box B, okay. This is the overlapping case, okay. Now the second overlapping case is like there is this box, then there is this box, okay. Here also they are overlapping. The third overlapping can be like there is this box, okay, and then there is this box, okay. Here the intersection area is this, and here the intersection area is the whole box itself, okay. So what I'll be doing is, if I run through all the cases, okay, so this is like ax1, ay1, and this is ax2, ay2, okay. Now if you look at the intersection areas, okay, in all of those cases, okay, so in order to calculate my intersection area, what I will need, okay, I will be needing this distance, okay, which is this width, and this distance, which is the height, okay. Now I can simply put a rectangle area finding formula, which is width into height, to get the area, okay. But in order to get this, okay, I need to get this coordinate value. So how can I get this, okay. I know this coordinate value is bx1 and by1, okay, and this coordinate value is bx2 and by2, okay. So for all this scenario, this coordinate system follows, okay, but this coordinate value will be what, okay. See, in all of those overlapping cases, okay, my bx1, okay, it has to lie between my ax1 and ax2, okay. If it doesn't lie between in this range, then that means the boxes are apart, they are not at all overlapping, okay. So what I can do is, I will get the width, or let's say intersection width. I'll be doing minimum of, okay, ax2, okay, and bx2, okay. So right now I'm calculating for this one, okay. Okay, so in all of the scenarios, okay, we need to find these coordinates, okay. So this overlapping coordinate, okay, this will be maximum of, okay, my ax1 and bx1. Okay, so if you see, okay, if I consider this and this, the maximum of it, okay, I'll get bx1, which is correct position here. Okay, the same rule you can follow for y1 also. Okay, then in this scenario also, okay, I have ax1 here, I have bx1 here. Okay, if I take the maximum, I will directly get bx1. Okay, now for this scenarios, okay, I have ax1 here, I have bx1 here. Okay, if I take the maximum of them, okay, I'll get this coordinate. Okay, now in all of these scenarios, I am assuming that my box A is something like this. Okay, but I have not put any sorting order, right? Okay, so if I would have sorted box 1 and box B with respect to their coordinates, okay, I will get these three scenarios. Okay, but I am not doing any sorting. That's why I need to consider maximum. Okay, it may happen this box becomes my box A, okay, and this box becomes my box B. Okay, so in that scenario, if I consider the maximum of these two coordinates, okay, I will always land up over the top left coordinate of my intersection rectangle. Okay, so yeah, so this coordinate will be the max, and vice versa, this coordinate will be the minimum of my bottom right coordinates. Okay, so minimum of x2 bx2 minus max of ax1 bx1. Okay, this will give me the x distance. Okay, now this I have to multiply with the height. Okay, but first I am calculating width, so I don't need to consider it. Okay, then there is inter h, okay, which is this height. Okay, the same thing we can run. Okay, since down the y-axis the values are increasing, so they will follow the same argument what we did for x. Okay, I'll simply replace this with y. Okay, cool. Now let's think of like when the boxes are not at all overlapping. Okay, let's see in this case what will happen. Okay, let's say this is box A, okay, and this is box B. Okay, here I have x1 ax1 and here I have bx1. Okay, I'm only considering x coordinates here because similar argument we can put for y coordinates. Okay, and here I have ax2. Okay, and here I have bx2. Okay, now if I consider max of mean of ax2 and bx2, this thing, so I will get ax2 here. Okay, I'll land up with ax2. Okay, now mean of ax2 bx2, I'll land up here. Okay, now for my top left coordinate, I'll be doing max of ax1 and bx1. Okay, now if you see here, if I consider the max of them, my bx1 will be lying here. Now in this scenario, my ax2 is less than bx1, which means this will give me a negative difference, right? Because this value will be higher than this. Okay, but in overlapping cases, this value will be always higher than this value. Okay, when non-overlapping, this value increases. Okay, so I can simply do a max of 0 here, so that my intersection area will always lie between 0. It will not go negative. Okay, we can do this, but it's a good practice to keep things like cut off to 0. Okay, same thing I can do here, max of this and this. Okay, so with this I can get the intersection area, so which will be inter w times inter h. Okay, so my intersection area is done. Now things are simple. I just need to calculate the area of this bounding boxes. So area A, this is basically ax2 minus ax1 times ay2 minus ay1. Okay, similarly for area B, I have to do bx2 minus bx1 times by2 minus by1. Okay, cool. Now if I calculate the union, okay, union will be area A plus area B minus intersection, so that we don't double count the intersection area. Okay, cool. Now finally, now one more check we can do. Okay, let's say I have been given 2 points. Okay, let's say the bounding box area is 0. Okay, so in that scenario it may happen like union becomes 0. Okay, now if I simply do a return of intersection over union, okay, I will get a div0 error. Okay, so I can consider, so if I'm considering that case, then I can have a check like if union is becoming 0, then I can directly return 0. Okay, cool. So I have my IOU here and this is my NMS. Okay, now if I run this, voila, everything passed. Okay, now if I submit, all test case pass. Cool. So this is the NMS algorithm. Okay, so if you search for like, let's say Ultralytics, which is a very famous library for training or inferencing object detection. Okay, so you will find this algorithm implemented in their code bases. Okay, so as you can see, like for this detection kind of a task. Okay, so this bounding box they are doing by applying NMS. There are some other algorithms are also involved. Okay, but the core algorithm is NMS. Okay, so yeah, if you go through their repository, you will find NMS implementation, and yeah, it's a very famous algorithm, and it may happen like in ML engineering interview rounds or AI engineering interview rounds. You will get a interview question like to implement NMS. So if you know how to do all this, and if you can explain to the interviewer, okay, what's the benefit of doing an NMS, what all factors we have to consider in NMS, okay, and where all scenarios we have to apply NMS, then yeah, I guess you will go do a good impression over the interviewer. Cool. So if you like this video, please do like, please do a like to this video, and subscribe to the channel. I'll be implementing more solution to TensorTonic. So yeah, just stay tuned to watch more videos. Thank you. Bye bye.